Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 14 in the cross-site scripting module titled Exploiting Cross-Site Scripting to Steal Cookies. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on cross-site scripting labs, and select lab number 14, titled Exploiting Cross-Site Scripting to Steal Cookies. All right, let's get started. This lab contains a stored XSS vulnerability in the block comments function. A simulated victim user views all comments after they are posted. To solve the lab, exploit the vulnerability to exfiltrate the victim's session cookie, then use this cookie to impersonate the victim. And then we have a note over here saying to prevent the Academy platform from being used to attack third parties, our firewall blocks interactions between the labs and arbitrary external systems. To solve the lab, you must use Burp Collaborator's default public server. So since we do need to use Burp Collaborator, that means we'll be using the professional version of Burp. All right, so the target goal over here is to exploit the stored XSS vulnerability in the block comment functionality to steal the victim's session cookie and then log in as the victim. Let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. All right, as usual, the first step is to find a cross-site scripting vulnerability. And the way we do that is we see if there's any functionality in the application where it reflects user-supplied input. So if we go down right over here, you could see that we could view posts. We click on that button and then go down and see that there's a comment functionality, and whatever comment we post gets posted under the application itself. So if this doesn't properly validate input and encode it on output, then it could potentially be vulnerable to a stored cross-site scripting vulnerability. So let's first add a normal comment and see which fields are being reflected. So let's say test1 for the name, and then the email is test@test.ca, and the website is http://www.test.ca, and we post the comment, and then we go back to the blog and go down. You could see over here, we've got the name field is being reflected back to us. Also, if you click on the name field, the website field is also reflected back to us, and then the comment field is reflected back to us as well. So all three fields need to be tested for stored cross-site scripting vulnerabilities. We'll start off with the comment field, and if it's not vulnerable, then we'll move on to the name field and then the website field. So we'll test for cross-site scripting using a really simple payload that just outputs a certain string to the web console. So we'll say script console.log, and we'll output the string hello, and then we'll end the script. And then for name, we'll just say test again, and email test@test.ca, and then website is http://www.test.ca, and post a comment. Now let's go back to the blog, go down. Now notice over here, our comment does not get displayed. This is the first indication that it was viewed as client-side code and executed as client-side code. But just to confirm, we're going to right-click, click on inspect, and then we're going to go to the console over here, and here we go. You see that it did print out that string in the console. And so definitely this is vulnerable to cross-site scripting. Now the next step is to see if this cross-site scripting vulnerability has an impact. And so what we're going to do is steal the session token cookie of anyone that visits this page over here. And to do that, we need to build our script. We'll do that in the notes.txt document, which I'll leave a link to in the description. So we'll start off with the script tag. And then we'll use fetch in order to output the cookie of the user that visits the page and then send it to our attacker-controlled server. So over here, we'll have the URL to our attacker-controlled server, which I'll add later. And then over here, we'll add the configuration for the request itself. So we'll say the method is a post method. The body is document.cookie. Essentially what this does is it says when you perform this request to our attacker controlled server, then in the body of the request, add the cookie of the user that visited the page. And then we'll say mode is no course. All right, so we add the mode to be no course over here because we don't want it to output a client-side error. So if you don't add this right over here, what will happen is that the browser will try to fetch the response of the request that you're performing to your attacker-controlled server. And since the browser is coming from a different domain than the attacker-controlled server, there will be a course error outputted that says, hey, you're not allowed to view the response. Now, this is a client-side error that will only appear in the web console. So view inspect, and right over here under the console, it'll appear. It won't actually prevent the exploit from working. However, we want this to be as discreet as possible, and so we don't want it to output any errors, and therefore we say no course, meaning that we don't actually want to view the response of the request. We just want it to perform the request. All right, this looks good. Let's add our semicolon over here. Let's copy this, close this off, put it in the comment field, and actually we forgot to add the link to our attacker controlled server. So if we go over here and then go to collaborator and then say get started and copy it to clipboard right over here and paste it in here. So this is the link to our attacker controlled server. This is the reason we needed to use Burp Suite Professional because it provides a server for us without us having to configure one. So we'll add HTTPS right over here. And so essentially over here, what's going to happen is when we post the comment, there's a simulated robot in the backend that is viewing the comments on all the posts. And essentially when it views the comment on this post right over here, the script will run and then it'll perform a post request to our attacker controlled server, and in the body of the request it's going to retrieve the cookie of the user that is viewing the page. And since this user is logged in, it'll retrieve an authenticated cookie, and then we're going to use that cookie to log in as the user. So let's copy this, paste it in here, and then name is test, email is test@test.ca, and then website is just the regular website, test.ca, and post the comment. Now we wait for the simulated user to view the blog, and we go back over here and click on poll now. And here we go. We get a ping to our attacker controlled server, and if we click right over here, you could see it's coming from the source IP 34.251.122.40. So that's the public IP of our victim user. And then if we look at the request to collaborator, the body of the request should include the session token. And it does. So over here, there were two cookies that were set for the user. One is secret and the other is session. I'm not sure what secret is, but I know session is definitely a session cookie. So what I'm going to do is copy the session cookie and then set it in my browser to see what type of user we just compromised. So if you right click over here and then inspect, go to application, and then under session over here, this is our unauthenticated session cookie. We're just going to add the authenticated one that we just compromised and then go to home. And right away you see we've got congratulations, you solved the lab. But if we go to my account over here, you could see that we've compromised the administrator session cookie, which means that it was the administrator that viewed our post. All right, so we successfully completed the exercise by exploiting the stored cross-site scripting vulnerability in order to steal the administrator's session cookie. In the next lab, we'll look at another case of a cross-site scripting vulnerability.